Hi guys, welcome to another session of the PYQs, previous year question discussion for the chapter Haloalkanes and Haloarene. MCQ 100 MCQ questions and all we discuss, and the most important question from the NCERT we discuss. Even if you can able to answer, are you known about the entire concepts or not? If you know the entire reaction from the chapter, what you learn in the NCERT and all, then definitely you can able to answer all previous year questions, because the board exam paper is purely based on the NCERT textbook. So study thoroughly the NCERT questions. Let's start for the first question from the previous year 2024. What's the board question they were asked from? Haloalkane Haloarene chapter. Dear all, first question for the chapter. Haloalkanes react with the AgCN to form isocyanide as main product. Why? You studied like this one. Haloalkane when react with the KCN, it will give you what? RCN, cyanide. Whereas haloalkane react with the AgCN, you will get what? RNC, isocyanide. What is the reason? You studied. They are called ambident nucleophiles. What is the main reason is KCN bond is an ionic bond, AgCN bond is a covalent bond. That's the main reason. Since KCN is ionic bond, it become K plus and Cn minus. So C will attack on R, you will get RCN. But AgCN is a covalent bond. AgCN is a covalent bond, so this bond won't break, where nitrogen will attack on R group. Therefore, you are getting RNC is the product. So main reason is KCN bond is ionic bond and AgCN bond is which one? Covalent bond. So covalent bond means nitrogen is the attacking side. So nitrogen will attack on R, you will get RNC. And the second question is allyl chloride. What is allyl chloride? CH2 double bond, CH single bond, CH2Cl. You know, this is called allyl group. What is allyl? Halogen connected to sp3, sp2, sp2. Why allyl chloride shows high reactivity toward SN1 mechanism? What is the first step in SN1 mechanism? Removal of halogen forming carbocation. You will get CH2 double bond, CH single bond, CH2 plus. What is this carbocation called? Allyl carbocation. This is our allyl carbocation. See dear all, allyl carbocation is more stable due to resonance. This pi bond is in resonance. So why? You know, the SN1 mechanism mainly depends on the stability order of carbocation. Am I right? So allyl chloride when undergo SN1 mechanism, first we get allyl carbocation. Allyl carbocation is stable due to resonance. So they are ready to undergo this reaction. Clear all of you? That is the answer for the second question B. And next one, haloarenes are extremely react. Let me take an example for haloarene, that is chlorobenzene. Haloarenes are extremely less reactive toward nucleophilic substitution. Yes, you can able to see this question in many previous year. Okay, I will discuss only here and carefully listen. If it is repeated in any other year, I won't discuss. Okay, carefully listen. This is our haloarene. For example, chlorobenzene. Why haloarenes are less reactive toward nucleophilic substitution? You know, if you want to substitute this nucleophile, first of all, the halogen you have to remove from that. That is very harder. That's a reason. You know, chlorine halogen removal from the benzene ring is very harder due to what? Partial double bond. You know, due to chlorobenzene can undergo resonance and they form what? Partial double bond between carbon and halogen. You know, double bond is a stronger bond and shorter in length, right? Because of the stronger bond, very harder to remove the halogen. One reason. Second reason why the halogen removal is harder, you know, in haloarene, halogen connected to which carbon? An sp2 carbon, it's having 33.3% S character. In haloarene, halogen connected carbon on benzene ring is what? sp2 hybridized carbon, it's 33.3% is the S character. So higher the S character, you know, this carbon is more electronegative. What? Higher the S character, higher the electronegative the carbon. So it holds the chlorine and all tightly. So because of these two reasons, halogen removal is harder from benzene. Therefore, nucleophilic substitution is harder on haloarene. So what is the main two reasons? Due to partial double bond. Double bond is stronger bond, harder to break. Second, due to high S character. Because of high S character, more electronegative the carbon, very harder to remove the halogen. These are the two reasons. Because of that, haloarene do not undergo nucleophilic substitution reaction, very lesser. They undergo very less reaction compared to haloalkane. This is our 2024 board question, my dear. And next 2023 board question. Answer any three of the following. Let us answer all of them. First one. Which isomer of C5H10 give a single monochloro compound C5H9Cl in bright sunlight? Bright sunlight, that means substitution reaction. If it want to give substitution reaction, it should be an alkane, right? Alkane only undergoes substitution reaction mainly. This is our direct NCERT question. You know what is the C5H10 compound? That is cyclopentane. You know this is CH2. What is this? CH2, 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 CH2. This is our cyclopentane. So cyclopentane when undergo chlorination, when it undergo chlorination in presence of bright sunlight, you can remove one H and place chlorine. You will get C5H9Cl. This, if you take hydrogen from any part of the cyclopentane, you will get only this product. Correct? So this is the compound. What is our answer? Cyclopentane is the compound with the formula C5H10. Give you only one product. Second question. Let's go for the B question. What is B question? Arrange the following compound in increasing order of their reactivity toward SN2 reaction. What is the order of SN2 reaction, my dear? Primary greater than, secondary greater than, tertiary. So 2-bromopentane. Let me draw the just outer structure. 2-bromopentane. This is our 2-bromopentane. You know it is a secondary haloalkane. And 1-bromopentane. 1-bromopentane is a 1, 2, 3, 4, 5. Okay, 1-bromopentane is a primary haloalkane. 2-bromo-2-methylbutane. 2-bromo-2-methylbutane is a tertiary haloalkane. You know that which will undergo faster reaction, my dear. Let me mark it as this is A, marking as this is B, and marking as this is C. Which will undergo SN2 faster, increasing order, right? You know, primary undergo reaction faster, so B undergo faster, then A, then C. What is the SN2 mechanism? Priority order, we have to consider the steric factor, right? Lesser the steric hindrance, lesser the bulky group, more the reactivity. And C question, why para-dichlorobenzene has high melting point? We know this is a repeated question in many years. This is para-dichlorobenzene. We know para-dichlorobenzene having high symmetry, right? Because of high symmetry, they can occupy, they can fit in the crystal lattice tightly. What is the reason? Para-dichlorobenzene have high symmetry, so they can fit in the crystal lattice tightly. Therefore, they are having high melting point. And D question, identify A and B in the following. Okay, let me just raise this question, all of you. What is the reaction? Please check it, please check it, please check it all. What is the reaction? The reaction is the cyclobutyl bromide is given, right? This compound is treated with a magnesium and dry ether. What happens when a haloalkane react with a magnesium in dry ether? You will get Grignard reagent, right? You will get cyclobutyl magnesium bromide. You know, magnesium plus the alkyl group minus. When it is treated with the H2O, you know H2O contain the ion H plus and OH minus, my dear. H2O contain the ion H plus and OH minus. So to the O minus, the H will attack. That means cyclobutane. And the byproduct is what? To the Mg plus OH will attack. So you will get MgBr and OH. So where is the product, my dear? So they are asking which is A and B. So this is what? A. This is what? B. Cyclobutane is the final product. Okay. So that is the 2023 board question. Now justify and arrange the following compound in each set in increasing order of their reactivity toward the displacement they ask. What is the displacement? SN1. What is the reactivity order of SN1, my dear? Tertiary greater than, secondary greater than, primary. You just analyze which is that. 1-bromobutane is primary, 2-bromobutane is secondary, 2-bromo-2-methylpropane is tertiary. Very simple. Marking as A, B, C, which is tertiary here. C is tertiary, then B, then A. Very simple. So SN2 mechanism, order primary, secondary, tertiary. SN1 mechanism, tertiary, secondary, primary is the order. Why the reason? SN1 mechanism follows stability of carbocation. This is the order. Now justify and arrange the following compound, namely in increasing order of their reactivity toward again SN1. SN1 means order tertiary, secondary, primary, my dear. Classify them. You know, here the halogen connected carbon connected to one carbon, it's primary. Halogen connected carbon connected to two carbon, secondary. Halogen connected carbon connected to three carbon, tertiary. Marking as A, B and C. Can you say which is the one more reactive toward SN1 reaction? Yes, C is more reactive, then B, then A. Tertiary, secondary, primary. Be very careful whether they are asking increasing order or decreasing order, okay? Increasing means higher and left side lesser, correct? Next one. Write the major product of the following reaction. This is chlorobenzene and concentrated H2SO4. You know, chlorobenzene, when chlorobenzene is a weak ortho para directing group. When you do heated with the concentrated H2SO4, it undergoes sulfonation and it will give you ortho and para product. What is sulfonation? SO3H group come to ortho and para position. You will get orthochlorobenzene sulfonic acid and para-chlorobenzene sulfonic acid. You know, para is always the major product. What is this reaction? That is our electrophilic substitution. You studied, no, nitration, sulfonation, like that. That's the one. And what is this reaction? HCl is there. H plus and Cl minus. Alcohol is there. One of the OH group will go with this H plus as water. So H plus and OH you should go, and then Cl minus come to that. Which OH group we have to take it? Dear, don't take this OH group. You know, this is involved in resonance stabilization. If you remove this OH, you will get the more stable benzyl carbocation here. You know, it is more stable due to resonance. So if two OH group comes like this one, please take this OH, don't disturb this one because this OH is involved in resonance stabilization. If you remove this OH, you are getting benzyl carbocation. So this OH and H go as what? H2O, and other OH remain as it is to the CH2 plus who will come? Cl will attack, right? Just our nucleophilic substitution. OH removing, Cl is adding. But which OH to remove? That's a question. This OH. What is this alcohol? This alcohol is, this question actually you will study in our alcohol chapter, okay? Alcohol chapter, this is a combination they asked here. This is a tertiary alcohol, copper at 573 Kelvin. Dear all, check the alcohol chapter video, you can able to see. This is actually a question from alcohol chapter. So this is a tertiary alcohol. Tertiary alcohol when react with the copper at 573. Now you just remember, copper at 573 is an oxidizing agent. Don't worry, you will study in alcohol chapter. I already told you, already we discussed there. And tertiary alcohol do not undergo oxidation, it undergo dehydration. What is dehydration? OH take from alpha, hydrogen take from beta, put a double bond. You will get CH3, C double bond, CH2, then CH3. Check it, okay? You will study in alcohol phenol chapter this reaction. As a combination, they given this with a haloalkane, one alcohol chapter question. Anyway, next one. Out of orthodichlorobenzene, you know, this is what we call orthodichlorobenzene and paradichlorobenzene. Orthodichlorobenzene and paradichlorobenzene, which has higher melting point. Let me take one more compound which is missing here, metadichlorobenzene. We studied the order of melting point of these compounds are, that's POM, POM. If they asking you the melting point order of ortho, meta, para, dichlorobenzene order is POM. Why para having greatest melting point? You know, because of high symmetry. Because of high symmetry of para, they can occupy in the crystal lattice tightly. The order is what? Para, ortho, then meta. So out of orthodichlorobenzene and paradichlorobenzene, which has higher melting point, mean paradichlorobenzene, because of high symmetry, they can fit in the crystal lattice. Next. Write the name of the product when benzene diazonium chloride. What is benzene diazonium chloride? N2Cl is reactive with Ki. Yes. What we studied? Potassium iodide. You know, this iodine go to benzene ring. We get iodobenzene. What is the byproduct? This K combined with the Cl. We get KCl and the nitrogen gas come out. Benzene diazonium chloride, when treated with the potassium iodide, we get iodobenzene. Next, write the structure of the major alkene formed by beta elimination of 2,2,3 trimethyl 3-bromopentane. Let me draw the structure of the compound first. Pentane, right? For 5 carbon. 2,2,3 trimethyl. Okay, trimethyl. 3-bromo. Okay, 3-bromopentane. Okay, this is the alkane we have, my dear. This compound, when undergo beta elimination with the sodium ethoxide, NaOC2H5. NaOC2H5. You know, NaOC2H5, sodium ethoxide is a strong base, like our alcoholic KOH. So beta elimination happen. What is beta elimination? You know clearly. Halogen go from alpha, hydrogen go from beta. Which hydrogen that you can select it? Mainly we can select the hydrogen from this beta, because this side there is no beta carbon, beta hydrogen. So we can get this one, CH3, 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 then CCH3, double bond, CH single bond, CH3, right? It's a major product. Actually, this is not the main product, but as per our NCERT, we can able to say like this. Actually, what happened, this CH3 group from the nearby that shifted here, double bond from this side, that is according to one methyl shift is there. As per NCERT theory point of view, it is not there. So we can take halogen from alpha carbon, hydrogen from beta carbon. We can make the double bond in the more substituted area according to Zaitsev rule. And next question, which of the following compound, the following is chiral? They are all chiral. You know what is chiral carbon? What is this carbon? This is CH3 carbon, this is CH2 carbon, this is CH carbon, this is CH3 carbon. What is this? This is CH3, CH2, CH, CH2, CH3. Correct. Check it here. In this compound, this carbon, I think it is chiral, because this carbon connected to bromine, hydrogen, methyl and ethyl. See, all are different. But here, all the carbon, is this carbon chiral? No, it contains 2 same group left and right. The carbon, all 4 bonds should connected to 4 different, then only it will be called chiral molecule, right? So, first compound is the one chiral in nature. Identify A and B in the following reaction. What is this? Bromobenzene. Bromobenzene, when react with the sodium and dry ether, yes, we know we get the compound called biphenyl or diphenyl. That is our Fittig reaction. Yes or no? Haloarene, when react with the sodium in dry ether, it undergo that that 2 bromobenzenes will join. You will get diphenyl or biphenyl. That is our Fittig reaction. But what about here? Haloarene, when react with the magnesium in dry ether, you will get Grignard reagent, phenyl magnesium bromide. Right? Phenyl magnesium bromide. We studied haloarene, how they behave with the sodium and magnesium metal. Next one. 2020, 2019, 2018, they repeated one question. Out of these 2 compounds, let me take the compound once again. Cyclohexyl is there with 7 CH2Cl and benzyl chloride. 2 compounds are given here. Question, which will react fastest with the SN1 mechanism? What is the first step in SN1 mechanism? Halogen will get carbocation, right? You check which carbocation is more stable. This carbocation connected to only 1 carbon, this is normally a primary carbocation. But this carbocation connected to 1 carbon, it's primary as well as it's benzyl carbocation. This is benzene with a CH2 is called benzyl carbocation. It is more stable due to what? Resonance. So this will undergo reaction faster. So SN1 mechanism, if they ask you, basically you have to go with the tertiary, secondary, primary. But here both are primary. Then you check which is more stabilized. This one is more stabilized because of the stability of the carbocation. Next one question 2020. CH3, CH2, CH2Cl is there. And one another CH2, CH, CH2, Cl is there. Which one is more reactive toward SN1 mechanism? Again, SN1 means halogen go first, carbocation form. Halogen carbocation. What kind of carbocation is this? This carbocation connected to 1 carbon primary. Even this carbocation connected to 1 carbon primary. But this one contains something special. You know, this is initially sp3 and sp2. This is our allyl carbocation. You know, allyl carbocation is more stable due to what? Resonance, my dear. Where resonance is possible in allyl carbocation, therefore it is more stable than primary. Therefore, allyl carbocation undergo reaction, or this compound will undergo the reaction faster. Next one, out of these two compounds, you can able to see, I'm not rewriting again, CH3 tri-CBr, it's a tertiary haloalkane. Even this is a tertiary haloalkane. Which one is more reactive toward SN1? SN1 means halogen go carbocation, halogen go carbocation. Both are tertiary carbocation here. You know, halogen, one is bromine, one is iodine. We know very well, if you consider alkyl fluoride, alkyl chloride, alkyl bromide, alkyl iodide, down the group, what happens to their reactivity? Down the group, their reactivity increases because fluorine, chlorine, bromine, iodine, down the group size increases, very easy to break the bond. So iodine is the best leaving group, it will make the reaction faster. So bromine and iodine, if it come, this will undergo reaction because carbon-iodine bond is very weak, easy to break, easy to undergo the reaction. Second one, write the product formed when para-nitrochlorobenzene. What is that compound? Para-nitrochlorobenzene. He is heated with aqueous NaOH. Aqueous NaOH at 443 Kelvin, followed by acidification. Followed by acidification. This is our Dawes process, my dear. Dawes process. You know, chlorobenzene, when treated with aqueous NaOH, we get sodium phenoxide, nitro group acid is there. When it is treated with Na acid, NaCl go out, this H go to this side, you will get para-nitrophenol. We will get para-nitrophenol. That is our Dawes process. Okay. And the third question is given as, why dextro and levo rotatory isomers of butan-2-ol are difficult to separate by fractional distillation? Please note it all. Fractional distillation method we are using if there is a fractional distillation is a separation technique. Okay, fractional distillation is a separation technique basically. And why dextro and levo rotatory isomers of this compound are difficult to separate? That means if there is a difference in their boiling point, if there is a difference in boiling point between the two components, then only we can separate by fractional distillation. Why dextro and levo of a compound you can't separate by fractional distillation means, what is the point? The dextro and levo of a same compound having almost a similar boiling point. So we can't able to separate by fractional distillation. There should be a small difference in their boiling point, then only we can separate by fractional distillation. Next question, out of chlorobenzene, okay, one is given chlorobenzene and para-nitrochlorobenzene. Okay, chlorobenzene and para-nitrochlorobenzene. Question, which one is more reactive toward nucleophilic substitution, where a nucleophile can substitute faster? We already said that halogen removal from benzene ring is very harder due to partial double bond and high S character. Here you can able to see one nitro group is there, you know, it's an electron withdrawing group. What happen if there is an electron withdrawing group? They withdraw the electron from the chain and make the CCl bond what? Weaker. Yes or no? If there is an electron withdrawing group, they withdraw the electron and make the CCl bond weaker. If it is weaker, you can easily remove the chlorine and you can easily bring the nucleophile. So electron withdrawing group, if they're on the ring, the removal of halogen is easier. Nucleophilic substitution can happen faster. So this one in undergo reaction faster, my dear. Careful about this question. Among all the isomers of molecular formula C4H9Br, let me draw all the structures first, okay. C4H9Br, the possible structures are CH3, CH2, CH2, CH2Br. This is one structure possible, and let me put one bromine on the second position. This is one bromobutane, so let me take it 2 bromobutane here, okay. Now let me take it one alkyl group, let me take it as a branch, okay. This is another possible. And one more is possible, I think a tertiary is also possible here. We can write tert-butyl bromide also, we can place it. Now the question is, which isomer, the one isomer which is optically active. Here all optically active mean there should be a chiral carbon. let me mark it as this is compound A, B, and then C, then D. Which is optically active or which one contain a chiral carbon? Can you tell me? I go with the B answer. The first question answer is option B because this carbon is chiral, my dear. This carbon is chiral. Is it? Because this carbon connected to bromine, hydrogen, methyl and ethyl. Yes, all are different. It's chiral. Second question, the one isomer which is highly reactive toward SN2, that means primary. Which is primary among this one? A, right? So this is the one undergo SN2 reaction faster. So this is the answer for second question. Last one, the two isomers which give same product on dehydrohalogenation with alcoholic KOH. Which all two compound on beta elimination give you same product? I think C and D are the correct answer. C and D are the correct answer. C and D are the correct answer for the last one. I'll show you here. Let me do the beta elimination. What is beta elimination? Treated with alcoholic KOH. You know, halogen go from alpha, hydrogen go from beta, make a double bond here, right? So you will get CH3, C, double bond CH2 and we get CH3 here. This is the product, right? Let me do beta elimination on this also. Alcoholic KOH, you know, halogen go from alpha, hydrogen go from beta. You will get CH3, C, double bond CH2. You will get CH3. Check it all. Is these two products are same or not? Yes, they are same. So C and D will give you the same product. Hope you're clear. Next one, why is chloroform kept in dark colored bottle? Yes, one of the important question. Many times we discussed in class. What is chloroform? CHCl3. Chloroform is highly reactive toward oxygen and in presence of light. The chloroform converted to a poisonous gas called what? Phosgene, COCl2. Phosgene, poisonous gas along with HCl. So in order to prevent this formation of the poisonous gas, we are keeping the chloroform in a wax lined and dark bottle because chloroform is highly reactive towards which one? Oxygen and light. Next one, why is tert-butyl bromide? So immediately draw the structure, no need to wait. This is tert-butyl bromide is more reactive toward SN1 as compared to N-butyl bromide. N-butyl bromide we can write like this one, right? N-butyl bromide. You know, first step in SN1 mechanism is remove halogen carbocation. This carbocation is tertiary, this carbocation is primary. You know, tertiary carbocation is more stable, so this will undergo reaction faster. That's it. And write the equation for the preparation of one iodobutane from one chlorobutane. One chlorobutane, what is that? You know, one chlorobutane is this one, right? One chlorobutane you want to convert into one iodobutane. That means this chlorine you want to exchange by iodine. That we have our Finkelstein reaction. What is Finkelstein reaction? Treat with the NaI in presence of dry acetone. You know, NaCl go out, you will get iodine. You will get CH3, CH2, 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 I plus NaCl. Very simple Finkelstein reaction. Second question B, out of 2 bromopentane, 2 bromo, 2 methylpentane, 1 bromopentane, which compound is most reactive toward elimination reaction? My dear, I'm not drawing the structure. You know, 2 bromopentane is a secondary haloalkane. 2 bromo, 2 methylbutane is a tertiary haloalkane. 1 bromopentane is a primary haloalkane, which will undergo elimination faster. Basically, primary, secondary, tertiary species, if they given elimination like a dehydration, beta elimination, something if they asking, that follow tertiary, secondary, primary, SN1 mechanism. Elimination reactions mainly follow SN1 mechanism, that is stability of carbocation is the factor. So which one is tertiary here? So 2 bromo, 2 methyl butane, that will undergo the reaction faster. Okay, and give the IUPAC name of this compound. Okay, simple. You know, double bond is there, halogen is there. They are all double bond having more priority than halogen. So 1, 2, 3, 4, 5. And you can see the bromine is there, methyl is there, alphabetical order, bromine is first. Therefore, the name is 4 bromo, 4 bromo, 4 methyl, 4 bromo, 4 methyl, total 5 carbon, right? Pent-2-ene. Pent-2-ene is the compound. 4 bromo, 4 methyl, pent-2-ene. Next question, give reason for the following. Presence of nitro group at ortho and para position increases the That already we discussed, my dear. Already we discussed, okay. Nitro group is a electron withdrawing group. When an electron withdrawing group is present on the haloarene, halogen removal is easier because when electron withdrawing group present, they withdraw the electron, make the carbon halogen bond weaker. Easily you can remove halogen, easily you can bring the nucleophile. Already we discussed that question. Para-dichlorobenzene has high melting point. Again repeating. Para-dichlorobenzene having high symmetry, so they can fit in the crystal lattice tightly. Thionyl chloride. What is thionyl chloride? SOCl2. Thionyl chloride method is preferred for preparing alkyl chloride from alcohol. Yes. We studied alcohol when react with SOCl2 will get RCl plus SO2 plus HCl, right? Why this method is best to convert alcohol to haloalkane? We know that these byproducts are two escapable gases. The byproduct are two escapable gases, so we'll get pure haloalkane, right? And then which alkyl halide from the following pair would expect to react more rapidly by SN2 mechanism? SN2 mechanism means primary is most, right? You know, this halogen connected carbon connected to 2 carbon, it is secondary. Here halogen connected carbon connected to 3 carbon is tertiary. You know, out of secondary and tertiary, which will undergo faster? Secondary will undergo reaction faster because here less steric hindrance. Define the following terms. What are enantiomer? Can you define, my dear student, what is enantiomer? Enantiomers are mirror images. We studied what are enantiomer and diastereomer. Enantiomers are mirror images but non-superimposable, right? They are mirror images but non-superimposable. Whereas diastereomers are no mirror images and non-superimposable. So enantiomers are mirror images but non-superimposable. What are racemic mixture? Racemic mixtures are enantiomer. Racemic mixtures are enantiomer which contain 50% dextro and 50% levo. So if it contains 50% dextro and 50% levo, they are optically inactive. Why? Because optical rotation of one cancelled by other. You know, dextro means it rotate clockwise and the levo means rotate anti-clockwise, right? So 50-50 means one dextro cancelled by other levo. So racemic mixtures are enantiomer. They contain 50% dextro and 50% levo. You know, they are represented by the symbol plus, minus or DL. And they are optically inactive because optical rotation of one cancelled by other. So study what are enantiomers and diastereomers like that. Racemic mixture. Even 2024 racemic mixture definition is a question. Why is chlorobenzene resistance to nucleophilic substitution? We already said due to partial double bond and high S character. Expand detail. Identify the chiral molecule in the following. Dear all, which is chiral? I think this carbon is chiral, this CH. Because this carbon connected to hydrogen, one methyl group, one isopropyl group, one alcohol. All are different. This carbon is chiral. There is no chiral carbon in this one. Write the structure of the product formed when chlorobenzene is treated with a methyl chloride. Okay, let me take chlorobenzene. Chlorobenzene react with what? Methyl chloride in the presence of sodium metal and dry ether. What is this reaction, my dear? This is our Wurtz-Fittig reaction. Haloarene react with the haloalkane. You know, both of the chlorine go with the sodium as sodium chloride. CH3 come to benzene ring. We get toluene. You know, two haloalkanes are combining with the help of Wurtz reaction. Two haloarenes are combining, forming biphenyl Fittig reaction. Here one haloarene react with the haloalkane. We get what? This is our Wurtz-Fittig reaction. The arene and the alkyl parts are joining. Next, write the structure of the alkene formed by dehydrohalogenation. What is dehydrohalogenation? Beta elimination of the compound 1-bromo, 1-methyl cyclohexane. 1-bromo, 1-methyl cyclohexane. This when undergo beta elimination. Beta elimination means alcoholic KOH. Form alkene, right? You know, halogen go from alpha, hydrogen go from beta. You know, this is beta, this is beta, this is beta. Please consider, please take the beta carbon from the ring, because then you will get the double bond in the more substituted part according to Zaitsev rule, that is major. Please don't consider this one. So take one hydrogen from this beta and make a double bond here. So product will be the same. Here one CH3 already there, one double bond come this side, either here or here, left or right. Please don't take this beta carbon because that double bond formed is less substituted one. This is more substituted one. Okay, that is another question. Now, out of these two compound, which is an example of allylic or vinylic halide? You know what is allylic? Allylic means it's connected to sp3, then sp2, then sp2. Vinylic means what? Only sp2, sp2. Check it all. Here the halogen connected carbon sp3 is connected to sp2, again connected to sp2. This is nothing but our allyl group. Here halogen connected carbon sp2, again it's connected to sp2. This is our vinylic one, right? Only based on hybridization we can find it faster. Among the isomer of pentane C5H12, write the one which one on photochemical chlorination. It means chlorination in presence of light yield a single monochloride. Many times we discuss the isomer is which one? Neopentane. What is the compound? Neopentane. What is the another name of neopentane? 2,2-dimethyl propane. See this neopentane when undergo chlorination in presence of light. See all these CH3 are identical, right? If you remove hydrogen from any of the CH3, you will get the same product. So suppose I am taking hydrogen from this, I want to add chlorine there. So you will get CH2Cl, here CH3, here CH3. So if you take hydrogen from any of the CH3, you will get the same product. Okay, so this keep in mind. This is a isomer of pentane, C5H12. What is the name? Neopentane or 2,2-dimethyl propane. This on chlorination you will get only one product. Next one. Draw the structure of the major mono-halo product. Okay. See, this is an alkane. This is bromine with a light. So, this is our free radical substitution reaction. So, from where you can take hydrogen and place bromine? Both of the carbon, you can remove hydrogen and put bromine. But one is major. Which one? I select this carbon. Please remove this hydrogen and place bromine there. Already one chlorine is here. It becomes CHBr and then CH3. Why that position is important? Because that position is benzylic position. Benzylic position. Benzylic free radicals are more stable due to resonance. So maximum try to remove the hydrogen from the benzene connected carbon. So that will be the major product. Okay. And here what is this? This is H plus Br minus, and this is what is the alkene. This is the carbon C. This is the carbon CH. Markovnikov's rule. Negative part goes to carbon with less hydrogen. Positive part goes to carbon with more hydrogen, and double bond becomes single bond. Here we have CH3 to the same carbon. Br will attack. That's a product. Right? That's our Markovnikov's rule. And what this reaction already we discussed before, H plus is there, Cl minus is there. This H plus need one OH group. Whether you take this OH group or this OH. I'm going to take this OH, so I will get benzyl more stable carbocation here. We can't take this OH because it is involved in resonance, right? So let me remove this OH and put Cl in this position. So we get benzene, one OH is already here. And in this side, we have CH2Cl as a product. Plus water we can write. 2017 question. Let's go 2016. Write the structure of an isomer of compound C4H9Br, which is most reactive toward SN1 reaction. SN1 reaction means stability, tertiary, secondary, primary. Check it whether tertiary is possible or not. We discussed this question before. And let me write the structure, this formula. There is a tertiary is possible. This is the tertiary, right? With this formula is matching. This is the tertiary. So what is the name? You can suggest 1, 2, 3. So the name is 2-bromo, 2-bromo, 2-methyl, 2-methyl propane. This compound will undergo SN1 reaction faster because it is tertiary. Correct. Again 2016 question, first one, chlorobenzene to biphenyl. How you can convert chlorobenzene to biphenyl? This is a biphenyl, right? That is Fittig reaction. So chlorobenzene react with the sodium in dry ether, we get which one? Biphenyl or diphenyl. That is our Fittig reaction, my dear. Fittig reaction. Chlorobromobenzene, when react with the sodium and dry ether, will get biphenyl called Fittig reaction. Okay, this is phenyl. Okay, this is phenyl. Okay, I'm just writing properly since it is chemistry. Each structures are very important, you know. Okay. Next, second is propene 2. Okay, let me take propene. This is what propene. Propene to 1-iodopropane. Simple reaction, my dear. Directly it is not possible. Let me add HBr in presence of peroxide. What is this rule? This is our anti-Markovnikov rule. Negative goes to this carbon, positive go to this carbon. You will get CH3, CH2, CH2Br. Now, but bromine we want to interchange by iodine. So, we can use sodium iodide in dry ether. So, we will get CH3, CH2, CH2I. Right? You will get iodopropane. The last one is given as 2-bromobutane. What is the compound? 2-bromobutane. 2-bromobutane to butadiene. That is what? Beta elimination. Halogen go from alpha, hydrogen go from beta, make a double bond between. Yes, you will get butadiene. What is the reagent for beta elimination? Alcoholic KOH can be used. Okay, simple question from 2016 conversion. Write the major product. I think this question we discussed now. See the repetition. Okay. This question already we discussed. Bromine where to place? They are all benzene connected carbon because this is benzylic position more stable. So the remaining you keep it there NO2 as it is. Here it becomes CH, Br and CH3. What is this reaction? This is our haloalkane react with the sodium. That is our Wurtz reaction. So but Wurtz reaction while writing students are making mistake. Careful. Two molecule of this one, right? Let me write this molecule like this one. CH3, CH3Cl. Is it same or not? This is 2-chloropropane. This is also 2-chloropropane. Let me take one more 2-chloropropane because Wurtz reaction is a combination of two species, right? And in between what we place 2 sodium. You know, this 2 sodium go with the Cl and this alkyl group join with this alkyl group. We will get the product as CH3, CH3. CH3. We will get these two products. This product 2,3-dimethyl butane. And what is this? Haloalkane react with the AgCN. You will get isocyanate, right? You will get CH3, CH2NC. You will get ethyl isocyanate. Clear all? So study the reaction always. Give reason. Carbon chlorine bond length in chlorobenzene. In chlorobenzene, this carbon chlorine bond length is shorter. Yes, it is shorter because involved in resonance it formed double bond. Double bond is stronger bond and shorter in length. Whereas in CH3Cl, such type of double bond formation is not possible. It exists as single bond. Therefore, the bond length is weaker and longer. The dipole moment of the NCERT question, okay. Dipole moment of chlorobenzene. You know, this is what chlorobenzene is lower than that of cyclohexyl chloride. Why it is so? You know, chlorobenzene in which chlorine when present on benzene ring, it having two effects. Which one? Minus I effect. Minus I means electron withdrawing effect. Electron withdrawing, and due to resonance it plus R effect, that is which one? Electron donating effect. So remember, when halogen when present on benzene ring, it having mainly two effects. Withdrawing effect as well as donating effect. That means minus I and plus R effect. So there is some cancellation. So its dipole moment is lesser. Whereas when halogen present on an alkane chain, its only one effect is there, minus I effect. So full dipole moment is upward. So it having highest dipole moment. And the one third question is, SN1 reaction are accompanied by racemization in optically active. You know, in SN1 mechanism, do you remember the second step? What's happened to the haloalkane, to the planar the carbocation, right? R dash. This is our planar, trigonal planar carbocation. In second step of SN1 mechanism, nucleophile can attack through in front or back side. Two side attack is possible. So there is a chance to get 50% dextro and 50% levo because there are two side attack is possible. Therefore, it can give racemic mixture. Why not SN2 mechanism? You know, in SN2 mechanism, in SN2 mechanism, the nucleophile is attacking through the opposite side of the halogen directly. Only one side attack is possible. Either it give full dextro or levo. So 50-50 chance is only in which one? SN1 mechanism. Therefore, SN1 give racemic mixture. Now, 2015 question, conversion. First one, aniline to aniline. We have to convert aniline to bromobenzene. What is the reaction we studied? First, diazotization. NaNO2 and HCl at a 0 to 5 degree. We get benzene diazonium chloride. This on treated with Cu2Br2 along with HBr or copper powder with HBr, we get bromobenzene along with the nitrogen gas. This is our Sandmeyer reaction or copper powder Getterman reaction also, we can choose it. Second one, how to convert chlorobenzene to 2-chloroacetophenone. Nothing but, my dear, this is our Friedel-Crafts acylation. Let me treat with the CH3COCl along with the N-hydrous AlCl3. Friedel-Crafts acylation. You know, halogen is a weak ortho-para directing group. The acyl group go to one ortho and one para position. So we need a COCH3, right? You know, ketone is main group. So this is 1, 2. 2-chloroacetophenone can be produced. What is the third one? Chloroethane. This is our chloroethane. This one, how you can convert into butane? Symbol reaction, my dear, you already got it. This is only 2 carbon here. This is total 4 carbon here. You want to double, that is Wurtz reaction. Treat with the sodium and dry ether can be selected. 2015 conversions easy. Now what happened when, again 2015, chlorobenzene is treated with the chlorine in presence of FeCl3. This is our electrophilic substitution. Halogens are ortho-para directing group. So this halogen go one ortho and one on para. So already one chlorine is there. One chlorine come to ortho position and one chlorine comes to para. Ortho dichlorobenzene and para dichlorobenzene we get, and this is major. Second one is ethyl chloride. What is ethyl chloride? C2H5Cl. Ethyl chloride is treated with the AgNO2. You know, it's an ambident nucleophile. Haloalkane, when react with the KNO2, you will get ONO. With the AgNO2, you will get NO2. So C2H5, NO2 can form it. Third one is 2-bromopentane. What is 2-bromopentane? This is our 2-bromopentane. 2-bromopentane is treated with the alcoholic KOH. That is our beta elimination. So you know, halogen go from alpha, hydrogen go from beta. Maximum try to take the hydrogen from the center area. Don't take this one. So you will get CH3, CH double bond, CH single bond, CH2, CH3. You will get penta-2-ene as a major product. Right? Again 2015, a simple question. Next, which would be undergo SN2 reaction faster? I think it's a repeated type of question. 2015. Which will undergo SN2 reaction faster in the following? You know, this is a primary haloalkane. This is a tertiary haloalkane. Primary undergo SN2 faster because of less steric hindrance. Draw the structure of the major product. 2014, my dear. This is an alcohol. Alcohol react with the PCl5. You will get chlorine, right? PCl3, PCl5 all are. Chlorine comes to the chain. So cyclohexane with the CH2Cl. You know the byproduct which all are getting by PCl5. You will get POCl3, phosphoryl chloride along with HCl. What happened to the alkene if you add HBr? It follow Marconico's rule. Negative part goes to carbon with less hydrogen. Positive part goes to carbon with more hydrogen. We get here, there is a benzene chain. Yes. Then we have CH2, CH, Br, then CH3. We can get it. Which halogen compound in each of the following pair will react faster in SN2 reaction? See, this is CH3Br, CH3I. Both are methyl, right? Both are methyl. So, which is the best leaving group, my dear? Iodine is the best leaving group. So, this will undergo reaction faster. They're asking SN2, right? And what about this one? You can able to see this is tertiary and this is just a this is just a methyl, that like a primary. So which will undergo reaction faster? This will undergo reaction faster because here is the less steric hindrance, here more bulky groups. Simple question. Give reason. First one, ethyl iodide. What is ethyl iodide? CH3, CH2I. Ethyl iodide undergo SN2 reaction faster than ethyl bromide. Yes. What is the question? You know, iodine is bigger in size than bromine. Because of the bigger size of iodine, the bond is what? Very weaker. This iodine is a best leaving group. It undergo the reaction faster. And second question, plus minus. What is plus minus indicate? It is a racemic mixture. Plus minus 2-butanol is optically inactive. What? You know, plus minus indicate that it is a racemic mixture. Racemic mixture contain 50% dextro and 50% levo. So optical rotation of one cancelled by other. Therefore, they are optically inactive. And carbon halogen bond length in halobenzene is smaller. Already we discussed carbon halogen bond. Carbon halogen bond in haloarene is very shorter. Why this bond is shorter? Because of partial double bond, right? Because of resonance. Because of resonance in haloarene, the double bond is stronger bond, therefore shorter in length. Then answer the following question, my dear. Here 2012 question. What is mean by chirality of a compound? Give an example. Chirality means if carbon all four valencies, if a carbon all four valencies are satisfied by four different groups or atom, then it is called a chiral carbon. What? If a carbon all four valencies are satisfied by different atoms or group, then it is called a chiral carbon. Let us give an example. We can see 2-chlorobutane. 2-chlorobutane. See this second carbon. This carbon connected to one methyl group, one with chlorine, one with hydrogen, one with ethyl. All are different. Therefore, it's called chiral carbon or asymmetric carbon. Second question, which one of the following compound is more easily hydrolyzed? Dear all, we discussed in MCQ session. Hydrolyzed mean mixing with the water. Hydrolysis, solvolysis, racemization, all indicating SN1 mechanism. So which will undergo SN1 mechanism faster? Let me take the compound. First one is CH3CHCl CH2CH3. 2-chlorobutane is given. Another is given CH3CH2CH2Cl. So they are asking you which will undergo SN1 faster. So remove halogen, carbocation. Remove halogen, carbocation. You know this carbocation is secondary. This carbocation is primary. Secondary carbocation is more stable. So this will undergo hydrolysis or solvolysis or racemization or SN1 reaction faster. Okay, 2011 question. Haloalkane easily dissolved in organic solvent. Why? You know, haloalkanes are less or insoluble in water because they cannot form hydrogen bond with water. And why they are soluble in organic solvent? When you mix a haloalkane with organic solvent, the formed bond having much strength. When haloalkane dissolve in organic solvent, the bond between haloalkane and organic solvent is which one? Having much strength. Therefore, they are soluble in one. What is known as racemic mixture? I told you it's a repeated question. Even 2024 board exam also they were asked. Racemic mixture with the racemic mixtures are enantiomer, which contain 50% dextro and 50% levo. So optical rotation of one cancelled by other. Therefore, they are optically inactive. Give an example. You can write anything with a plus or minus 2-butanol or 2-bromobutane. One should chiral carbon should be there. That's it. Of the two bromo derivatives, which will undergo SN1 reaction faster. Let me take the compound here. C6H5. What is C6H5? This one, right? C6H5, CH, then CH3, then 1Br. And we have another with the C6H5, then CH, another C6H5, and with the Br. Okay, this is the compound given, which is more reactive toward SN1. Dear, what is SN1 mechanism? Remove the halogen carbocation. Remove the halogen carbocation. So which carbocation is more stable? You know, this carbocation connected to 2 carbon secondary. This carbocation also connected to 2 carbon secondary. Both are secondary, and which is more stable? I go with this question because there are 2 benzyl ring. 2 benzyl ring mean more resonance is possible. Therefore, more stable the carbocation. So this will undergo reaction faster by SN1. So see how many questions are based on SN1 and SN2 mechanism. SN1, SN2 mechanism, beta elimination, nucleophilic substitution. Why the nucleophilic substitution is harder in benzene, the haloarene, due to the partial double bond and high S character. Many conversion question, the dipole moment, the melting point. These are the main area of the chapter haloalkanes and haloarene. Hope you clear which all area you have to revise for your upcoming board examination. So sit and practice all the reaction. If you don't study the reaction again, study at the reactions and their reactions once again, then back to the question and crack it. Wish you all the very best. Do maximum effort in all organic chapters and get good marks. Wish you all the very best.